So anyways, I had already emailed you the question I had, which was question number 4 from web assignment 3.
Okay.
My issue is like I don't even really know how to do a hypogeometric because that's what he said in class, that we needed to do it like a hypogeometric distribution.
Yes.
So like how exactly do you even like set that up? Because I don't even think we, like, to be honest, I don't even know if we did like an example of hypogeometric in class. Because I like don't have anything in my notes, and I think there may have been something on the slides.
Very sure. Let me open the homework 3. So it's a quality control problem, right?
Yes, the one with the defective something being defective in a group.
Oh, sure. So I can share the answer with you because like you already like submit the homework, so I can share my answer with you and share my group, share my
Well,
screen.
no, I don't.
Thing.
I mean, I don't have the answer. Like, I don't have anything.
Yeah. I know.
Like, I just
Professor
need like
Bartman
help, like Yeah.
didn't give you the answer, but like, because I did all the problems myself, so basically I have the answer and I'll
Oh, so
give
you're
you
gonna
guys
show
if
your
you have.
screen?
Yeah, I show my screen.
Okay, yeah, that's fine. Because I just need like help. Like, I can understand like I went to the one-on-one tutors, and like I was telling her that like I can understand like how to do the problems like once I'm like shown, and like I can do the equations, but like setting it up and like determining it is like where I have troubles. So like I didn't even know like this was a hypogeometric question. Well, one, because I didn't even know what that was, and two, because
Okay, so basically a hypergeometric distribution is like stand on the concept of combination. So
okay.
so if you see like here the formula, like the denominator and numerator, it says like 4 choose 3, 6 choose 1, right? So basically first you have to understand what's the meaning of those combinations. Right, so basically if I said 4 choose 3 is how many possible combinations I have. If I choose 3 items from like 4 items, how many ways I can choose it. And there's some formula to calculate it, but basically you have to like, I think that's on the slides. How can you like calculate the combinations? And in this,
Okay.
right, so basically here
Wait, so number 3 was also hypogeometric?
yes, it's also hypergeometric.
Oh, I did binomial. Wait, why wouldn't 3 be binomial?
Because you have different options. So basically a binomial distribution is like tossing a coin. You only have 2 possible outcomes. That is a key feature to the binomial distribution.
Correct, but I thought they were only asking for they were only asking for 3 and 4. That's like what I assumed. Wait, let me see if I still have the question up. Yeah, homework 3, the operating system. Yeah, the inspection sites, they were all, because I mean, like the question was kind of just worded a little confusingly. So like maybe that's why I understood it as.
I agree. So but like when you look at here my answer, so basically the probability of results being positive, you can separate that into 2 parts. First, 3 sides functioning, and second, four sides functioning, and you just have to add those two probabilities together, and that is the answer. And and how to add those two possibilities together, like how to calculate the individual, how to calculate different ones. Basically, the
Mm-hmm.
method is similar. It's just hypergeometric distribution. First, you need to choose three from four sides, and then because you're gonna choose four sides in total, and in the first step, you have already choose three sides from like four sides, and then you have remaining six sides, and you're gonna choose one. So that is how what's the meaning of four choose three times six choose one, and
Mm-hmm.
that is just the frequency of finding. That is the frequency, or we see the number of finding the combinations that meets the question. That is the numerator, and in denominator, that is a total number of the sides possibly. So we're gonna um, find four sides out of 10 in total. So that is 10 choose four. That is in the denominator. Basically, we use the number of appropriate observations that meets what the question asks, divided by the number of total observations we can possibly find. So that is
Okay.
the possibility.
Okay. Okay. I see how that makes sense. And then I'm also looking at the number two, and like, could you just like scroll up by
Oh,
chance
okay, so number two
so
is
I
a
could see like all the, because I did the
perfect
binomial
example
for
of
number two.
binomial. Okay.
Yeah, that one was very straightforward to me, and I did only 9, 10, and 11 as well. But now I see that you're doing after you got all of the, like, why are you doing this whole other equation after you get like the, I don't know what they're called, like the probabilities for each number?
Yeah,
Like, why are you like where it says like using a calculator? Like, why are we doing that part? Is that like
because
all
you're
of the
gonna
values
compare.
added together?
Yeah, yeah, that's essentially what I'm doing. Because basically the question is asking. Um, so basically, there's a term. A gambler offers you to pay even odds if you get blah blah blah. So that means pay even odds means if you win, he gives you $1. If you lose, you give him $1. So that is the rule of like pay even odds, right? So basically, essentially means the same amount. So what I'm
Mm-hmm.
gonna compare here is the probability of getting 9, 10, or 11 heads and 50%, right? If the probability of getting 9, 10, or 11 heads is greater than 50%, then I will play in this gamble. If it's smaller than 50%, then I will just
Mm-hmm.
leave. So a binomial distribution cannot directly give me the probability of getting 9 heads or 10 heads or 11 heads together. No, it cannot. We have another way to approximate the probability of getting 9, 10, and 11 heads. And later
Mm-hmm.
you will learn it's called like a z-score or something, and you're going to use that z-score to approximate the probability of getting 9, 10, and 11 heads together. But using a binomial distribution, that is a very precise, very like accurate method to calculate those kind of probability. And you can only calculate the probability of getting 9 hits, and maybe by doing it again, calculate the probability of getting 10 heads, and doing it again, calculate the probability of getting 11 heads. And lastly, you have to add them up together. And you're going to compare
Okay.
that last number to
And
50%.
why do we add them all together at the end?
Because here, if I get 9 heads, or if I get 10 heads, if I get it, or I get 11 heads, I win the game. So there's 3 scenarios where I win the game and I get $1. So when I compare the probability to 50%, I have to add those 3 probability um, of those 3 scenarios together. I have to add them
Mm-hmm.
up and then compare to 50%. Right? If the question says a gambler offers me to pay even odds if I get 9 or 11 heads in 20 tosses, should I take the
Mm-hmm.
bet? Then I only add the probability of P1 and P3. Right? I don't care about P2.
Okay. Yeah, that makes sense. Because it's only asking for those 3.
Yeah.
Okay. So then back to the back to the original question, which was number 4.
Yep.
Like, how do I even like start by like how did you know that it was a geometric or the hypogeometric distribution? Like, how could you tell? Like, based off of like the context of the question,
Mm,
if that makes
I
any
think
sense.
yeah. I think like the basic feature of hypergeometric distribution is first um, the all the possible ways you can choose is some sort of combination. Like in question 3, you can see in denominator is 10 choose 4, right? That is
Mm-hmm.
all the possibilities I have. And in the numerator, you're gonna choose from 2 different groups. So basically, I'm dividing this 10 in question 3. I'm dividing this 10 sides into the first group, 4 sides, and the second group, 6 sides, right? So kind of
Mm-hmm.
I'm doing the whole thing in 2 separate ways. First, I'm doing one group, and then I'm doing another group, and I'm choosing some number from first group, and I'm choosing another some kind of number in the second group, and adds up, I accomplish this goal. That is like the basic feature of a hypergeometric distribution. And here, if you look at my answer in question 4, like I'm not using the formula of that hypergeometric distribution, but actually you can. So maybe you can try it out after the office hour. You can try it out like using some format similar to what I'm writing here in question 3. But in question 4, I just find maybe what I'm doing here is more simple. So I didn't use the similar format as question 3, but it's just hypergeometric distribution. Um,
Wait, so why did you? What is the process you're doing then?
okay, so that's a question we're here talking about. So basically, every hypergeometric distribution, you have 2 methods to do that. If the like you can choose either one. You can choose either one. But sometimes the method I'm doing in question 4 is way more complex because I'm doing a lot, and a lot. Like there's so many terms. Here I only have 6 terms because I only have 6 defectives, right? So it varies in different scenarios, but I think it's good if if you can understand both 2 methods. Um, so basically, let's talk about my methods here, and you can, if you really understand the hypergeometric distribution, you can write another formula, another equation similar to question 3.
Um. Okay. Well, I mean, like the way you do it, it's like it like looks easier. I just like I'm not really getting understanding how like where these numbers or where these fractions are coming from. Like, how did you get 34 over 40, and then you multiply by 33 over 39?
Okay, so first, it's it. Let's look at a question. Like if you have the prompt, I read it out anyhow. It's lots of 40 components. Each are called acceptable if they contain no more than 5 defectives. The decision
Okay.
procedure used it to inspect components drawn at random until a defective is found. If this
Mm-hmm.
occurs in the first 6 components, the lot is rejected. If the first six drawn are non-defective,
Oh,
the law is passed. Find the maximum probability that a non-acceptable lot will be passed. Find the maximum probability that an acceptable lot is rejected. So first, let's find the probability of a non-acceptable lot will be passed. What does that mean? It will be passed. It
that
means like
more
in the
than or
first
less than
six
six.
drawn, right? In the first six drawn, the there's non-defective. So basically, this could be a defective. But as long as in the first six drawn we found no defective, then it is passed. Right? Basically, I'm making a mistake, but that is how the system is working, right?
Mm-hmm.
So what's the probability of the first six drawn are non-defective? Basically, it's the maximum probability that a non-acceptable lot will be passed. What does that mean, a non-acceptable lot? It means I have six defectives, right? Because I want to find the
Mm-hmm.
maximum probability. It's very possible I have seven defectives, I have 10 defectives, I can have 20 defectives, and I'm still a non-acceptable lot, right? But here I'm gonna find the maximum probability that something bad can be passed. So I'm assuming I only have six defectives, right? Is that clear?
Mm. Yeah, that's clear.
Right, if I have
But
20 defectives, then the probability of
uh-huh.
I'm being passed is very, very low. But that's not what I want to find. I'm going to find the maximum probability. So first,
Okay.
the assumption is I only have six defectives. That's in the like second line.
Mm-hmm.
And what is the probability of first six drawn, a non-defective, given that I have six defectives? Right? So what I'm multiplying here is first the probability of no defective in the first drawn, right? So I have 40 things being considered, but there's 24 of them are non-defective. The probability of randomly choose the first one and find non-defective is just 34 over 40.
Okay.
But in the second try, things get a little bit different because now I only have 39 remains. That's the total. That's the total features I have. And then the probability of getting another non-defective feature is only 33 divided by 39 because I'm in the second round. I have
Okay.
already I have already took one away instead of
But why do you go up from why is your range 40 through 35? Like why do you stop after 35?
because the question says if the first six drawn are non-defective, then it is passed. So after the sixth try, the probability of still getting non-defective feature in the sixth try is 29 divided by 35, right? That's my sixth try. After
Mm-hmm.
that, I still find non-defective feature. That means the
Okay.
lot is already being passed. I'm not gonna do any test anymore. But by the way, that could cause a problem. That like I'm making a mistake, but that's the system works.
Mm-hmm. Okay.
And by the way,
Well that makes sense.
you can like rewrite this formula in the similar terms as question three, and I guess you can try it out.
Okay. Like in the way that was I guess taught to us. I don't even know where to find the hypogeometric like formula in the slides. Like I don't think we ever went over these in class. That's the issue. That's why I like didn't know how to do it. Because like
Okay,
we only went over binomial, Poisson, and then we did I think exponential. And then like we ran out of time before he could do another one.
Okay, so yeah. So probably you guys should talk to Professor. I will talk to him as well to like maybe
Okay.
to speed up a little bit. But I will post those answers and like after you covered those materials, you can look back and those answers
Hmm.
and hopefully it makes sense.
Okay, and then one more question I have is at the bottom, you're doing the thus P being rejected equals one minus like P apostrophe.
Yep.
Why are we doing that? And how are you getting that number?
Because here we are considering acceptable lot is rejected, right? So
Hmm.
it's like kind of hard to calculate what's the probability of an acceptable lot being rejected because again I'm gonna find the maximum probability that an acceptable lot is rejected. So here my assumption is this acceptable lot has 5 defectives. Right? If it has one defective, if it has 2 defectives, the probability could be much lower, but I'm gonna find the maximum probability. So first, my underlying assumption is this acceptable lot has 5 defectives.
Okay, but like I'm still like a little confused on that explanation. Like, why is it we're choosing the maximum like probability over instead of the oh well they're both maximum, the maximum probability of the acceptable one and not the non-acceptable one? Is it
It
because
has
we
two
already know the
questions. Like we have two
non-acceptable is going to
questions.
be
Um,
okay?
right, there's 2 questions. First, the maximum probability that a non-acceptable lot being passed, and second, the maximum probability of an acceptable lot not being passed. Right? There's two separate questions.
Oh, so the where you're saying that thus P being rejected equals that has nothing to do with number one?
Yeah, it has nothing to do with number one.
Oh, okay. Okay,
Like,
that's where I was getting
right. So
confused because I
basically,
thought it like
yeah. So basically, here you have to assume the acceptable lot has 5 defectives in order to find the maximum
mhm,
probability. But here something difficult arise,
okay.
right? It's being rejected. That means I can maybe am detecting the defective in my first trial, maybe in the second
Mhm.
trial, maybe in the fifth or sixth trial, right? I don't know. This is a very huge problem in terms of calculating the probability because I'm like basically multiplying the 6 numbers together, and
Mhm.
there's could be some changes in the first numbers or in the second numbers or in the third numbers, right? It could happen because I don't know in which trial I find the defectives. So
Okay.
here the methodologies I'm using is thinking reversely, right? Instead of considering uh, what is the probability of being rejected, I first find the probability of being passed because because there's there's 2 reasons of thinking like this. First, if I have already calculated the probability of being passed, then I
Mhm.
just need to use 1 minus that probability, and I get the probability of getting rejected, right?
Okay.
This is the first
Mhm.
reason because essentially they are just the same thing. And the second, but the most important reason is it's much more easy to find the probability of being passed. Because being passed means during the first trial, I find no defectives. During the second trial, I find no defectives. All the way during the sixth trial, I find no defectives. Every trial is determinant, is being determined. There's no like variabilities, there's no uncertainty. That makes it much more easier when I like multiplying those 6 numbers together,
Mhm.
right? So my P prime is the probability of first 6 strongs are non-defective, which means I'm going I'm going to pass this test. And here, like the formula or you see the equation is very much similar to the part one of this question. The first one is non-defective, right? But remember, I only have 5 defectives this time. This law only have 5 defectives. So the probability of the first one being passed is only 35 divided by 40, not 36 divided by 40. Because I can randomly choose anything from those 35 good features and divide it by the total features I have. I have 40 features. And then all the way until the sixth trial, 30 divided by 35. That is the probability of non-defective during the sixth trial, which is the probability of being passed. And then I use 1 minus that p prime. I get the probability of being rejected.
Okay, I see now. Okay, I think that was all the questions I have, and I'm gonna work on this now, and I
Right?
think I'll see if I can find if I can find anything about the hypogeometric like formula like he wants to do, or like try it the way that you did it with number 3.
Yeah, definitely. It's gonna help a lot. But
Yeah,
like
and
right
then
now, I didn't look at the professor's slides, so I don't know like what materials you have been covered.
okay.
But here's the thing, like I'm I'm gonna be more open with the due time. I mean, because sometimes the professor is a little slow, so
Yeah, a little.
yeah, I discussed with him, and sometimes I mean, if you submit the homework like a little later, I'm gonna say it's fine.
Yeah, I know. I'm sorry. I didn't mean to. I wanted to get the meeting over, like meet with you like on Tuesday,
Yeah,
but then like too much like came up, and I had to like go to a whole nother too much like other tutoring. But like yeah, I guess like yeah, he goes a little all over the place. Somebody in our class told me that we've like we went from like chapter 2 to chapter 3, jump to 4, jump to 5, then like jump back to 2, and like then we went to 4, and like today we were on 5. Like it doesn't make any sense. Like there's really no clear direction. So
yeah,
yes, you're not wrong when you say that it's very complicated to keep up.
yeah. I guess like you could ask the professor like what's the reading materials for today's class. So the most important thing is like the class materials and the slides. I have to like
Okay.
try to understand all of them, but like if sometimes you are confused, like some materials confused you guys, you could look it up on the textbook, right? So you just ask a professor like what chapters will be covered in this class, something, and
Okay.
maybe you could spend like half an hour on the textbook. It makes things clear.
Okay. Perfect. Well, thank you so much, and
Sure.
thank you for that info. Because
I
that's
might.
gonna help like so I'm not as stressed.
Yeah, it'll be good. It'll be good. This is a very challenging class, and I mean the average performance of the students of this section should not be very good. So
Oh.
so just try to yeah, and that's a real question. Like I'm doing this like the second time. Like I have 1 semester experience. So just work harder because the finals, the midterms are not gonna be easy.
Oh. I mean, okay. Like
Yeah,
that you put it pretty point blank, so I'll try. I mean, like,
yeah,
I mean, he told us we have like, what are they called? Um, Markups. Is that the word? Like, where you
yeah.
can like, oh, corrections. We can like correct our thing, I think, or we can take like a remake. Either way, I don't
Yes,
know. Well, but
yes,
like, yes, hopefully that Stern curve better work. That's all I'm gonna say.
definitely. Like I will Yeah. One problem is like the professor don't have like a solution to those homework. So I would probably like create a Google Drive something and I post my
Okay.
answer because I did all those questions when I took this class. So hopefully that would
Oh,
help.
you've already taken with this exact professor?
Yes.
Oh, that's so interesting. Wow. So you're really you really know firsthand.
Yeah.
I mean, okay, I guess that's like good info to know.
Sure.
Sure. Sure is correct. Um,
Yeah.
okay, well, thank you. I guess I'll relay the message to whoever I see
Yeah.
about the
Yeah,
what you
that's good.
said.
Also, you can check the answer. Like basically, if you have this exactly the same answer, it's very possible that you did the formula or equation right.
Okay, well, yeah,
Okay,
I get that. Okay,
sure.
well, thank you then.
Yeah,
Have
see
a
you
good
next
one.
time. Have a good one.
See you next time.